Today's lesson, we are going to talk about the limit of a sequence, Tn. So we're still in our series and sequence unit. We already know how to calculate a limit. More importantly, we're going to look at limits as x approaches infinity. So just as a refresher, if we think back to our limits unit a few short months ago, we talked about the limit of a function. And we actually did a lesson on limits at infinity. So today's lesson is really just going to review that. First thing I should try is direct substitution. So if you want to copy this example down, and then we'll work through it. So if I replaced all of these x's with infinities, think about what would happen in the numerator. And remember, infinity is not a number. It's the process of getting bigger. So if my x values are getting bigger and I square them, well, and then multiply them by 5, this term's just going to blow up. It's going to get bigger. So will this. And then I'm subtracting 1. Well, I'm going to have a bigger term plus a bigger number minus 1. I think it's fair to say, or we can all agree, that this numerator is just going to blow up. It's going to get bigger. The denominator is going to do the same. Okay? Some people might say, well, this is going to infinity. This is going to infinity. You have infinity minus infinity. That's going to be 0 plus 6. No. Think about this. This term is going to be blowing up quicker than this one. Right? If you put a 2 in, you're going to end up with 8 minus 14. But if you put a 10 in, you're going to end up with 200 minus 70. Okay? So it's always going to be getting bigger down here too. That's no good. Okay? Direct substitution leads to infinity over infinity, which is indeterminate. So who remembers what to do? How do you calculate the limit as x approaches infinity of a rational function? Divide everything by the highest power present in the denominator. Perfect. Okay? So in this case, if I look to the denominator, I've got 2x squared minus 7x plus 6. What's the highest power of x? An x squared. So I am going to divide everything in the numerator, the 5x squared plus 3x minus 1, and the 2x squared minus 7x plus 6, everything in the denominator. I'm going to divide them by x squared. This is mathematically legal. What would I get if I divide 5x squared by 1x squared? I'd get a 5. So I write the limit as x approaches infinity. This would be 5. What about 3x divided by x squared? 3 over x? And negative 1 divided by x squared? Negative 1 over x squared. 2x squared divided by x squared would be 2. Negative 7x divided by x squared would be negative 7 over x. And 6 divided by x squared, well, that doesn't simplify. That's what we're at. Now I can do some direct substitution. What happens to all of these terms that have the x's in the denominator? What happens if you take 3 and you divide it by an increasingly growing denominator? You get 0. So this rational expression is going to become 5 plus 0 minus 0 over 2 minus 0 plus 0. I end up with 5 over 2. That limit, or the limit as x approaches infinity of this function, would be 5 over 2. And when we were talking functions, that would mean the further right I move, the closer I would come to a height of 5 over 2, or 2.5. We're going to use the same process today, only we're talking about sequences. And we're going to talk about 2 specific types of sequences. We're going to talk about converging and diverging sequences. So I believe you should have these notes. You don't have that one? All righty. Right there? And do you have the worksheet?
Yeah, I have the worksheet.
Okay, so you're good. Everyone else have the notes? We're good? Okay, first of all, a converging sequence has a limit. So you can add this to your sheet. Here's an example. We've got a quarter, 2/5, 3/6, 4/7, and it keeps going on. Now it says it converges, means it does have a limit. How could we figure out what that limit is? Well, first of all, note what it says in the box. It says the above sequence was generated using the following general term. Tn is equal to n divided by n plus 3. So this is the first term, T1. It was found by plugging a 1 in for n, 1 over 4. This is term 2, 2 over 5. Term 3 was 3 over 6. Term 4 is 4 over 7. Now, one way to actually figure out if it converges is to just find some increasingly larger terms. So maybe I'll go to term 10. What would the 10th term equal? If I fill a 10 in for n. 10 over 13. You with me? And I'll just write it above. What would term 100 be? Hundred over 103. Very good. And what about term 1000? This is a legitimate way to try and solve whether or not the sequence converges or diverges. This would become 1000 over 1003. Anyone notice what it's converging on yet? It's converging on 1. Exactly. Okay? Now, what we would do to solve that algebraically is we would find, it says what happens if n is a very large number? Well, that's what I was trying to show here. As n becomes larger and larger, you can see that the sequence is converging on 1. We could write that using a limit. I could say the limit as n approaches infinity is a very large number. So we'll say n is going to infinity. Of the expression n over n plus 3. If you try and do direct substitution, this is going to give me infinity, a large number in the denominator, or sorry, numerator, and I'd have a large number plus 3, so an even bigger number in the denominator. Infinity over infinity is indeterminate. It's no good. How do I solve a limit at infinity of a rational function? I would divide everything by the highest power of, in this case, n, that's present in the denominator. So just like I did in my opening example. What is the highest power of n in the denominator? N to the first. So I'm going to divide the numerator and the denominator by n to the first. And that is going to give me the following. I'll end up with the limit as n approaches infinity of 1 over 1 plus 3 divided by n. N divided by n is 1. N divided by n, 1. 3 divided by n, 3 over n. What happens to this term right here in the denominator? 3 divided by an increasingly larger denominator. It's going to 0. So this is actually going to equal 1 over 1 plus 0. 1 plus 0 is 1. 1 divided by 1 is 1. And Laughlin's answer that it converges on 1 is verified. So a converging sequence has a limit. This sequence right here converges on 1. There is also a diverging sequence. A diverging sequence does not have a limit, or there is no limit. So add this to your sheet. Here's another sequence. 1, 2, 3, 4. It says it diverges or no limit exists. How did they make this sequence? Using the following. It's just an arithmetic sequence with an A value of 1 and a D value of 1. Is there any pattern, or is there any like rhyme or reason to this? What would the 10th term be? 10. What would the 100th term be? 100. 1,000, and so on. As n gets bigger, what's happening to my sequence? It's not converging on 1. It's actually blowing up as well. It's getting infinitely large. What happens if n is a very large number? Tn is a very large number. It's the same number. If I try to write this as a limit, to calculate the limit, remember, n is very large. That means n is approaching infinity. So that's what we're working with. Direct substitution. It works. Okay. I don't get infinity over infinity or negative infinity over positive infinity. Okay. I end up with just infinity. And what that means is the limit does not exist. Sequence diverges. Is that all right? Flip over, you have another example. Okay. I don't know that you have these, so I'll get you to copy them down. So we want to decide whether each sequence converges. This means has a limit, or whether it diverges, the limit does not exist, or has no limit. The first example, we have a sequence 2, 4, 8, 16, 32. What would the next term be? 64, and then the term after that, 128, 256, 512, 1024, so on and so forth. Is it converging on a specific number, or is it just wildly out of control and going to get bigger and bigger and bigger? It's going to get bigger and bigger and bigger. So if it's not approaching a specific value, we say that it has no limit and that it what? Diverges. Okay? Now, if we wanted to get a little technical on this, I could ask you, like, what type of sequence is that? It's geometric. It's got an A value of the first term, or T1 is 2. If it's geometric, Brody's telling us that it's got a common ratio, which can be found by taking any term and dividing it by the term in front of it. So 4 divided by 2, 8 divided by 4, 16 divided by 8, 32 divided by 16. What do I get for the R value? 2. It's general term. What is the formula for calculating a geometric sequence? A times R to the power of n minus 1. Excellent. And in this case, I can replace the A with a 2, the R with a 2. I could also simplify this. What's the rule when you multiply powers with the same base? Like suppose you had x squared times x to the third. You add the exponent. So I write the base down again. The base is x. I add the exponents 2 plus 3, and I get 5. Yes? Do you agree that these both have a base of 2? So therefore, I could say Tn equals 2, not 4. I don't multiply them. I just write it down. And then I add the exponents. Well, what's this exponent right here on the red 2? What's 1 plus n minus 1? If I group my like terms, this one would cancel that one. And I'd have 2 to the power of n. And I could see, now that if I write the limit as n approaches infinity of 2 to the power of n, it's not a rational function. This is an exponential type. We worked with those a few months ago as well. But look at direct substitution. If this exponent gets bigger, this whole power also gets bigger. I would say equals infinity or does not exist. With me? What about this one? 3, 1.5, 0.75, 0.375, and so on. It converges. Okay? What is it converging on? Careful. 0. Okay? It's not going to go below 0. It's not going to go into the negative values. It's not going towards negative infinity. It's actually converging on 0. And you can add that. Anyone know what type of sequence that is? What's the first term? A is 3. Does it have a common difference or a common ratio? 1.5 minus 3 would be negative 1.5. 0.75 minus 1.5 would be negative 0.75. It doesn't have a common difference. It actually also has a common ratio. What do you get when you go 1.5 divided by 3 or 0.75 divided by 1.5? A half. Tn is going to equal 3 times a half to the power of n minus 1. I could say the limit as n approaches infinity of 3 times 1/2 to the power of n minus 1. What's that going to equal? What's it converging on? 0. Now, for this particular question, you might put some bigger numbers in for n. Okay, I could try a 10. What's 10 minus 1? A half. Okay, sorry, 9. What's a half to? What's a half? I know that's what you said. That's my bad. Okay. What's a half to the power of 9? What's 1 to the power of 9? It would be 1. 2 to the power of 9 would be 512. Then I would have 3 times 1 over 512, or 3 over 512. The 11th term would be 3 over 1,024. The 12th term would be 3 over 2,048. But you can see that the numerator is going to be 3, the denominator is going to blow up. It's converging on 0. Couple more examples here. It says, suppose we have a sequence defined by Tn equals n over 2n plus 1, where n belongs to the natural numbers. Generate the first 4 terms of the sequence. What would term 1 equal? If I fill a 1 in for n, I'd end up with 1 over 3. Good, Leah. If I fill a 2 in, numerator's 2, 2 times 2, 4 plus 1, 5. Term 3, 3 over term 4. 4 over what? 4 over 9. And it's going to keep going. Now, does anyone know what the limit as n approaches infinity of this would be? Think about the opening example. What would it be? Not 1. What's it say it's converging on? Yeah, converging on 0.5 or 1 over 2. Okay? Remember the shortcut we talked about a few months ago. If the degree of the denominator, end of the first, is the same as the degree of the numerator, you can find the limit by dividing the leading coefficients. Or, if I divided everything in this expression by the highest power of n present in the denominator, this is what I'd end up with. 1 over 2 plus 1 over n. This is going to go to 0. I'm going to have 1 over 2 plus 0, or 1 over 2. Is that okay? And we say, as n increases, or as n approaches infinity, Tn approaches 1/2. Symbolically, you write this: the limit as n approaches infinity of the expression n over 2n plus 1 equals 1/2. Some shortcuts that we discussed a while back. If the degree of the numerator and denominator are the same, then your limit will be the quotient. So divide the leading coefficients. N squared in the bottom, n squared in the top. 1 over 3 is the limit. If the higher power is present in the numerator, the limit does not exist. So this would be converging. This would be diverging. And the last one, it's also converging, the last situation, if the denominator has the higher degree. It will converge on 0. So those are your 3 situations. Let's see if we can apply them here. If I asked you to find the limit as n approaches infinity of n plus 5, try direct substitution. Should always try that first. If you get infinity over infinity, then do some extra work. In this case, if I fill a larger and larger number in for n and then add 5, this is going to blow up. It's diverging. Or the limit does not exist. All right. Example 2 here. I'll try the same thing. What happens if I fill a larger and larger number in for n? The numerator is going to blow up, as is the denominator. This is no good. Okay, it can be infinity. It could be 1 over infinity. That would be 0. It can't be infinity over infinity, or negative infinity over negative infinity, or negative infinity over positive infinity. So what do? I divide everything by the highest power of n present in the denominator. So what is that? Look to the bottom. I've got an n to the first. Simplifying. I end up with 3n over n, 3, plus 1 over n. 4n over n is 4, minus 2 over n. As n gets bigger, these two terms will go to 0. I'll have 3 plus 0 over 4 minus 0, which is 3/4. Now, if I had used the shortcut and I compared the degree of the denominator with the degree of the numerator, I would notice that they have the same degree. If that's the case, we can take the leading coefficients, the 3 and the 4, and just divide them. That would be this situation right here. These are the questions I'd like you to try for homework. Make sure to like and subscribe.